Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 4, Section 2, Part 3. Today we're going to start talking about chemical reactions, and let's take a look at electrolysis. So looking at this, we have an experimental setup, which is an electrical current transfers a large amount of energy into the water. And the observations we can make is that the mass of the water decreases over time and the volume of this gas increases. So what is our hypothesis? Let's say our hypothesis is that this is water vapor. So let's see how that plays out. Observations. When cooled, the gas does not condense into the liquid water. One of the gases burns or combusts, and one of the gases causes a flame to get brighter. So does that sound like water vapor? No, it does not sound like water vapor at all. This is something you should know about because we have decomposed water. And what are we getting? Your clues? One gas burned, one gas caused a flame to burn brighter, and it comes from water. So if you guessed that you get hydrogen and oxygen, you would be correct. So we get, out of every 2 molecules of water, we're going to get 2 molecules of hydrogen and 2 molecules of water. Excuse me, oxygen. If you notice, both hydrogen and oxygen are diatomic, which means they come in pairs. So another thing is, let's go back and look at this one more time. If we notice, you have 2 molecules for every 1 molecule of oxygen, and our hydrogen, the one that combust, has twice the volume. So we did this freshman year, if you recall this experiment. The decomposition of water. It was a chemical reaction. So the energy from the battery, from the electric current, was high enough to cause a chemical change, because we know chemical changes usually take more energy. And there was a chemical reaction. So let's talk about chemical reactions. Please write this down. Is a process that rearranges atoms in a substance to produce a different substance. A chemical change is the result of a chemical reaction. So please write down this chemical equation. 2H2O in the liquid phase is decomposed into 2H2 gas plus O2 gas. And then on the left side are the reactants, and on the right side are the products. And these subscripts tell you how many atoms of that element are in each molecule. So this tells us that there are 2 hydrogen atoms in each water molecule. Whereas the coefficient, the big number in front, tells you how many molecules are in a balanced equation. So in a balanced equation, where we don't ignore the law of conservation of mass, 2 molecules of water form 2 molecules of hydrogen and then 1 molecule of oxygen. So let's look a little bit more at chemical equations and balanced equations. So if we have 2H2O goes to 2 molecules of H2 and 1 molecule of oxygen, this is a chemical equation. So please write this down. You have, not everything, but write down H2O, arrow H2 plus O2, and then reactants on the left and products on the right. And then oxygen, hydrogen, oxygen, hydrogen. And fill out how many oxygen atoms there are, how many hydrogen atoms, how many oxygens on the product side, and how many hydrogen. Okay, if you had said 1 oxygen, 2 hydrogens, you'd be correct. And then 2 oxygens and 2 hydrogens, you would also be correct. But we have a problem because this is an unbalanced equation. So it is, you don't have the right number of oxygens. You might say, well, let's just put a little subscript right there and then we'll have H2O2. But you can't do that because now you have hydrogen peroxide instead of water, and whatever was in that water or whatever drank that water is going to die. So you don't have the power to change that chemical. What do we do? All right, so either write this again or you can change your coefficients if you want to. So if I write coefficients, now fill out how many oxygen atoms do I have, hydrogen, and then on the right side. Okay, so if you said 2 oxygen atoms and 4 hydrogen atoms on the reactant side, you'd be correct. And 2 oxygen atoms on the product side and 4 hydrogen atoms, you would be correct, because that coefficient means you times these. So I have 2 times 2, 1, 2, 3, 4 water molecules, 1, 2, 3, 4 hydrogen atoms on the water molecules, excuse me. Okay, so just like we talked about, these big numbers in the front are the coefficients. They tell you how many molecules there are. And the left side's reactants, right side's products, and then the reaction arrow. So please write this down. The rules of balancing a chemical equation. First off, determine if the equation is balanced. And please write the italics part as well. Count the number of each kind of atom on either side of the arrow. If it is not balanced, use coefficients. So H2O becomes 2H2O. So you cannot change the subscripts. So you cannot say H2O becomes H3O or H2O becomes H2O2. Cannot change the chemical. You can have more molecules, but you can't change the chemical itself. And then you check that the equation is balanced. Count the number of each kind of atom on either side of the arrow with new coefficients. So then you have to multiply the coefficient by the subscripts. So instead you would have 2 times 2 is 4, and then 2, and this is a 1. You have 2 oxygen atoms. Okay, so is it balanced? Please write this down. Iron reacts with oxygen to form iron oxide. And then a little table, reactants and products, iron, oxygen, and fill out how many atoms of each are on the reactant side and the product side. If you said 1 iron and 2 oxygens, and then 2 irons and 3 oxygens, you would be correct. Good job. But there's a problem. It's not balanced. 1 doesn't equal 2, 2 doesn't equal 3. You cannot just magically produce oxygen and iron atoms. So we are going to add coefficients, not subscripts. All right, so you can either make another one or you can just fill in your old one again. So we're going to be adding coefficients, and what coefficient should we add? 4, 3, and 2. So you may have said, well, why didn't we just add 2? And let's talk through this a little bit. So if I added a 2 here, well, then I would have 2 irons there, which is great, but I would only have 3 oxygens still. And coming over here, you can't have 3 oxygens if they come in pairs of 2. You can only have 2 or 4. So when that happens, you always have to go back and double it. So my 2 becomes 4, and then that was a 1, so that becomes a 2. So now I have 4 iron atoms and 2 iron oxide atoms. So I have 1, 2, 3, 4 iron atoms. And then I have this 2 times 3 is 6. 1, 2, 3, 4, 5, 6 oxygen atoms. So how do I get 6 oxygen atoms over here? Well, they come in pairs, so I need 3 pairs to get 6. So I put a 3 there, and I have 6 atoms total. Wonderful. Let's look at another example. So please write down the equation for photosynthesis. 6H2O plus 6CO2 yields C6H12O6 plus 6O2. So these are both gases that are the leaf takes in, and then as we know, photosynthesis occurs in the chloroplast, and it forms sugar and the byproduct oxygen, which is good for us. So please make a little chart, reactants and products for carbon, oxygen, hydrogen, and fill that out. Okay, so if you said that there are 6 carbons on the left side, you'd be right, 6. And then let's just go on the reactant side. And then oxygen, we've got 6 here, and then 6 times 2 is 12. 6 plus 12 is 18. Yep. And then hydrogens, we have 6 times 2 is 12. We have 12, and you could count them as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Coming over here, we have glucose, 6 carbon atoms. We have hydrogen, 12 of them. And then we have 6 oxygens plus 6 times 2 is 12. 6 plus 12 is 18 oxygens. Okay, so the number of atoms and the number of moles are conserved. Good. So let's just see, verify that that equation is balanced. So if we have 6 moles of water times, rounding it to the nearest whole number, 18 grams per mole, we would have 108 grams of water plus carbon dioxide. We would have 6 moles times 44 grams per mole, 264 grams. And then glucose, 1 mole of it times 180 grams per mole, 180. And then 6 moles of oxygen times 32, 192 grams. And then if we add up each side, we have 372 grams of atoms, of stuff. So we have not disobeyed the law of conservation of mass, and we have the same number of atoms and mass on one side as the other, so we did it correctly. Good job. Okay, please write this down. Conservation of mass. It is a law that states the mass remains the same in a chemical reaction. So the mass of the products has to equal the mass of the reactants. So that means a chemical equation must be balanced. You cannot break the law of conservation of mass. And let's go into the third aspect. We talked about reactants, we talked about products, let's talk about energy. Okay, when we're talking about energy, we're talking about the first law of thermodynamics. So please write this down. Any energy lost or gained by the system, the reactants and products is the system, is going to be gained or lost by the surroundings, which is everything else. So compounds store potential energy in the bonds between the atoms. So there is energy in those bonds. And when you break those bonds, that energy is released. So the energy absorbed when new bonds are formed. So making new bonds takes energy. And depending on the chemical reaction, either more energy is released when you make a compound or more energy is absorbed when you make the compound. So to review, when you break bonds, you give off energy, and when you form new bonds, it takes energy, and sometimes the amount of energy given off is greater, and sometimes the amount of energy taken in is greater. So there's either a net gain or a net loss. So if more energy is absorbed, we call that an endothermic reaction. The energy is considered like a reactant, like it's on the left side of the equation, and an example is photosynthesis. So endothermic means it's taking in energy during that chemical reaction. So photosynthesis, we know, takes in energy because it takes sunlight for photosynthesis to occur. So what happens if more energy is given off, more energy is released during a reaction? Well, that's called an exothermic reaction. And it's kind of like energy is a product, like it could be on the right side of the equation. So the opposite of photosynthesis is cellular respiration, and we know the job of cellular respiration is to release energy, is to make ATP available from those stored bonds in glucose. The energy stored in the bonds of glucose, we release that so that your body can use that in the form of ATP. Also, combustion is an example of an exothermic reaction, and we know that because we use combustion to give off energy to heat ourselves. In our next video, we are going to talk about enthalpy, which has to do with energy changes in how much energy there is. So I will see you then. Bye.